Video on the Doppler effect. Which is part of the third module, Waves and Thermodynamics, in the Year 11 Physics course. So the Doppler effect is something which is familiar to all of us in everyday life. If you hear emergency services driving past, you'll definitely notice this effect. It's basically a phenomenon in physics that describes the change in frequency or the pitch of a sound, or a light wave even, as an observer moves relative to the source of the wave. In other words, let's imagine here's a road, here's an amber with a siren, here's someone standing on the footpath. Now, as the amber approaches you, so it's traveling, let's say, at some velocity, v, to the right. The reason why there's such a high pitch is because the waves are getting compressed, okay? The amber is approaching you, the waves from the sound are coming towards you, they're getting compressed, okay? And those that are behind the amber, they get spread out, okay? They spread out and you hear a lower pitch, okay? If someone was standing at the back of the amber, so as the amber was, let's say, amber is driving past towards the right, this person here, this observer, would hear a high pitch, and then eventually as the amber moves away to the right, they'll hear a low pitch. Okay, and similarly for this person here, this observer. So let's do, so here's the actual formula, the relationship for the velocity of the sound wave and the velocity of the source. So I should say a formula. So the frequency f dash is the frequency heard by the observer. Okay, and that's equal to the frequency. So that's the observed frequency. That's the sorry, I should say f dash is the source frequency. Okay, it's the frequency being emitted by the source, which in this case is the siren. F is the observed frequency. Okay, the frequency heard by the observer. Okay, because the Doppler effect is all about relative frequencies. Okay, and we can express these two frequencies in terms of the velocity of the sound wave plus the velocity of the sound wave heard by the observer, divided by the velocity of the sound wave minus the velocity of the source. Okay, so V sub wave is the velocity of the wave, the sound wave in this case. Okay, it's typically around 340 meters per second in air. V sub source is the velocity of the source, okay? Okay, relative to the medium. Let's suppose that the source was also moving, which in this case, the source isn't moving, the observer. Apologies. Velocity of the source is in the siren, my bad. Okay, so it's the velocity of the amber in this case. I'll do an example to illustrate this effect, Doppler effect. So let's suppose we're asked to determine the frequency of sound from a source. Let's say it's a amber. Given that the velocity of sound, V sub wave, is 340 meters per second, and the amber is moving along at 15 meters per second, and let's suppose that a car is heading towards the amber in the opposite direction, okay, at 25 meters per second, and the frequency of sound heard by the person in the car is 902 hertz. So we need to work out f prime, f dashed. Okay, the frequency of the source, which in this case is the amber. How do we do that? Well, we use the Doppler effect formula. F prime is f velocity of the sound wave plus velocity of the observer all over velocity of the sound wave minus velocity of the source. So let's plug in some numbers. So the frequency heard by the observer, by the person in the car approaching the ambo, is 902 hertz. The velocity of the sound wave in this case is given. It's just 340 meters per second. The velocity of the observer is just 25 meters per second. That's the guy in the car. The velocity of the sound wave, 340 meters per second. Once again, the velocity of the source, which is the ambo, is 15 meters per second. Plugging all of this into a calculator, 1013, roughly 1013 hertz. Okay, so there's a difference, an observable difference here with the frequencies. So the frequencies are both different. Just a sanity check, checking that the numbers make sense. Difference in frequencies for the two observers. And that's the Doppler effect.